Okay, so we left off in our lesson on chapter 3.3 at this point, so we'll continue from here. It says, for h of x equals 2/3 x minus 5, find the value of x for which h of x equals -7. We got to think about this question for a little bit. Let me think about this, because normally they would tell me the x value, and then I have to figure out the y, or the f of x, or the h of x. Normally they tell me the input, and I figure out the output. You put something in, I figure out what comes out. But notice this time what's different. They're saying to find the value of x, the input basically, for which the output or the outcome or the h of x, which is on this side, is a -7. So it's sort of in reverse, but we can still figure it out. And how we'll do that is instead of the h of x, we'll write what the h of x equals. So we'll substitute a -7 for the dependent variable, or the y, or the h of x, or there's so many words we can call it, right? We can call it the dependent variable. We can call it the range, part of the range. And then that's where the -7 goes, and then we'll just write the rest of this equation down. 2/3 x minus 5. We'll just write everything down. And now we just need to solve for x. We can do that in 2 steps. Add 5 to both sides. Add straight down here. -2 equals 2/3 x. And then in order to get rid of this -2/3, since it's multiplying, we do the inverse operation, which is to divide. And so how do you divide fractions? Well, you just multiply by the reciprocal. So multiply this side by a 3/2. That cancels out the 3's and the 2's. And then multiply this side by a 3/2. The 2's cancel out, and we're left with a -3. Okay, so if we put in if the outcome was a -7, what we put in to get that would be a -3. It'd be written like -3, -7. And then, so you can put in lots of different numbers. Remember, variables mean that they vary. I could put in a different input and come up with a different output. I'm not going to do another example right now, but let's go ahead and try another equation and see how we do. Remember, it's written in function notation. So it has g of x equals 1/3 x minus 2. I do want you to take notes in this. On the top of your journal, before you take the note, label it 3.3b, and so that or the instructional aide can look for what we're grading. It's easier for us to find. It also helps if you put little lines, by the way. Okay, so now it's asking us to do it, and it's saying define x. So find the x again if the g of x is a -4. So instead of the g of x, I'm going to substitute in that place a -4. Bring everything else down. I'm going to add 2 to both sides because I want to solve for this x if I know what it equals. So we'd have a -2 equals 1/3 x. These would cancel. Then how do you get rid of a 1/3 x? You multiply by 3. I like to actually write it right next to it, but I didn't leave myself enough room this time. So I'll write it by 3. That cancels these out. And I'll multiply this side by 3. So we'd have a -6 equals x. Okay, we found our x. Yay! But and then we already know our y because it says if the y were a 3. So we have our answers. I'm sorry, if y were a g of x were -4. So the answer would be -6 and then -4. Again, we could try it with different numbers if we want, but this is what you should have in your notes. Good. Okay. You can also graph in function notation. This would be in the slope-intercept form, y equals mx plus b, which is a review from middle school, but we haven't covered it this year. So I'm not sure everybody would know what that means right now. But there is other ways to graph it. Here's the steps. Do write these steps down in your notes 3.3c. First step is make a table. Second step is to plot. And the third step is to draw the line, or graph it, if you will. So let's make our table. And you can really substitute any numbers you want, but I like to choose numbers that are predictable so there's a constant rate of change. So I'm going to do a 0, a 1, a 2, a 3, and a 4. And see my constant rate of change as x is going up each time. It's really nice to do that. You can confirm that it's a linear equation, it's a straight line, if there's a constant rate of change for the y, although you might already know it's a straight line because it's in the y equals mx plus b format. Okay, let's substitute these in. Now notice this time we're substituting in for the x. We're trying the x values. Let me close that email. So if x is a 0, what would the y be? So the f of x, which I just called the y, is the same, but instead of a x, I'm putting a 0. Instead of this x there, I'll put a 0 plus 5. So f of x would be 2 times 0 is 0. 0 plus 5 would be 5. So if you input a 0, your output would be a 5. You input a 0, your output would be a 5. And then we just need to do this multiple times. So let's just do it again. F of x equals 2. Instead of an x, though, we're substituting in a, well, we tried 0. Let's try the next number. Well, 1 is now the x, plus 5. F of x equals 2 plus 5. F of x equals 7. And I can already see the pattern that every time x goes up 1, y is going up 2. So I made a table. I need to plot these points now on the coordinate plane. So if x is 1, f of x would be 5. So if x is 1, I go over 1. F of x would be 5, I'd go up 5. There's your first point. If f of x is a 2, whoops, I'm sorry, I did that wrong. If x is 0, f of x would be 5, not 1. So 0 and 5. If it were 1, it would be 7. If it were 2, it would be 9, which would be kind of off our screen here. Just draw a line connecting these points and draw a continuous line through them. So that's how you would do it through graphing function notation. Okay, it's your turn to try it. I want you to try 4, 5, and 6. Remember to look back in the video if you need to. Last question is, this graph shows the number of miles a helicopter is from its destination after X hours on its first flight. So notice what we're looking at. We're looking at the number of miles a helicopter is from its destination. So there's a place it starts, and then it leaves that place. And the f of x is the distance in miles that it went. And this is the hours it took to go those distances. So in 3 hours, it has gone 300 miles. That makes sense. On its second flight, the helicopter travels 50 miles farther. So it's going more distance. It's going to 350, right? But increases its speed by 25 miles per hour. The function, notice now it's not giving it to us in a graph. It's giving it to us in an equation. Now, we can turn that equation into a graph or a line, but right now it's just the equation. It's in function notation. It says the function f of x equals 350. Well, we know the distance is 350 because it traveled 50 miles more distance, minus 125. We're minusing 125 because that's the speed it's traveling. It's going 25 times the amount of hours that it's done that. And that will represent the second flight, where f of x is the miles, the number of miles the helicopter has flown from its destination after x hours. Which flight would take less time, the equation or the graph? In order to find out, we would just do the same thing we did a second ago. We'd make our chart. You'd put x in one, f of x in the other. And then you choose values. I'm going to start with these values 0. We already know 0, but we'll start 0, 1, 2.